In the last video, we studied that substances expand on heating and contract on cooling. And we saw the thermal expansion in case of solids, and we also saw the examples for it. Now, today in this video, we are going to see the thermal expansion in case of liquids. A very good example would be that of milk. You know very well, when you boil the milk, it increases in volume, it expands in volume. Let's see few characteristics of liquids. In a very well liquid, they do not have a definite shape. They take the shape of the container. So in case of liquids, the linear expansion and the surface area expansion, it's not observed because they do not have a definite length or definite area. But liquids have a definite volume. Volume means the space occupied. Space occupied. So, since they have a definite volume, the volume expansion is observed in case of liquids. Volume expansion. When we heat a liquid, we always take the liquid in a container. We always take the liquid in a container. So when you heat the liquid, it expands in volume. So when you heat the liquid, the solid container also, it expands. The volume expansion in case of liquids, there are two. One is called the real expansion, and the other one is called apparent expansion. Apparent expansion. Apparent means the one which is visible to us. Now, to understand the real expansion and the apparent expansion, let's draw a flask. Let's make a flask. We have got out here a glass flask, and in the glass flask we are going to take colored liquid. A colored liquid, so it is easier for us to see the level of the liquid. Let's take the level out here. So we have taken a glass flask container, and in the container we have taken a colored liquid, the level of which is marked as O. Now we are going to heat the liquid. On heating, you know very well, the substances expand. So after some time, let's see the level, let us take the level increases to, let's mark it B. This is the increased volume of the liquid. Now this increased volume, it is the apparent expansion. Apparent expansion from O to B. From O to B. Now, what really happens out here? Let's just see. When we heat the liquid, this one, the container with the liquid, when we heat it, what happens is, at first the heat reaches the container. And you know very well, container, that is the solid, expands on heating. So at first there is expansion of the container, that is the glass out here. Now I'm going to draw the dotted one, meaning the glass has expanded. When the glass, that is the container, expands, the liquid now rushes to fill up the extra volume because of the expansion of the glass. And now the level of the liquid falls. So let's take the level as A. After some time, the heat reaches the liquid, and now the liquid now expands to B. Expands to B. Now the level from A to B, this portion out here is the real expansion of the liquid. So we have got two types of expansion, real expansion and apparent expansion, because of the expansion of the container as well. So let's write out here A to B, that is AB, would be equal to OB plus OA. And AB we can write out here is the real expansion. This portion out here is the real expansion. Will be equal to OB. This portion OB is the apparent expansion, which is seen by us. Apparent expansion plus OA. OA, this volume is the expansion for the vessel. Expansion of the container. So that is why we have got real expansion and apparent expansion for the liquids. Now let's see here. So we also have the coefficients for the real expansion and coefficients for the apparent expansion. It's given out here in the book. Kindly go through it. Out here, coefficient for real expansion, you know very well, for earlier we had denoted the volume expansion with the help of gamma. So for the real expansion, gamma R will denote it, the real expansion will be denoted by gamma R, subscript R, and the apparent expansion will be denoted by gamma A. Okay. Then mark out here, put this one out here in a box. Gamma R, which is the coefficient of real expansion, would be equal to your gamma A, that is the coefficient of apparent expansion of the liquid, plus gamma subscript V denotes the expansion of the vessel. So gamma R is equals to gamma A plus gamma V. Next we have a term here called anomalous expansion of water. This you have already done in the lower classes. You know very well, water, it expands on being cooled below 4 degrees Celsius. This property is called the anomalous expansion of water. Water above 4 degrees Celsius, it follows the general rule, that is, it expands on heating and contracts on cooling. But below 4 degrees Celsius, it does not follow this rule. It follows just the opposite, meaning it expands on cooling and contracts on heating. So above 4 degrees Celsius follows the general rule, below 4 degrees Celsius follows just the opposite. This abnormal property of water below 4 degrees Celsius, it is said to be anomalous expansion of water, and it has got great importance in the marine life. Let's take some water in a glass and let's okay, the level till here. Let's put this in a freezer. When we put it in a freezer, it changes to ice. It solidifies. So, solidify, and it changes to ice. We see that when it changes to ice, the volume increases. Initially it was less. Now the volume of ice, it increases because of the anomalous expansion. We have seen that below 4 degrees Celsius, the water expands on cooling. At 0 degrees Celsius, this is the freezing point of ice. That is below 4 degrees Celsius, it is expanding. That is why the volume of ice is greater than water. And since the volume is greater, its density will be less. That is why ice floats in water. ice floats in water. It can be explained by this property. Another thing is the aquatic plants and animals can survive in the cold region because of this property. Let's draw a pond out here. Suppose we have got a pond out here where the aquatic plants and animals are there. In the cold regions where the temperature is 0 degree or falls below 0 degree Celsius, what happens is the topmost layer of the pond, it changes into ice. So there is a layer of ice at the top of the pond here at the surface out here. And this ice, okay, because the volume is more, it floats, so there we have got a layer of ice at the top. Now this ice, it's a bad conductor of heat, so it does not allow the outside cold to enter below here and the warmth in the water to go outside. That is why fishes can survive. Only the topmost portion will be ice, and rest below it will be still in the liquid form. The water will be still in the liquid form, and so the aquatic plants and animals can survive even when the temperature outside is 0 degree or below 0 degree Celsius. It can be explained by the anomalous expansion of water.